Okay, let's talk about area of circles here. Let's just say we have a circle, and in this particular circle we've been given a radius. So we have the formula to actually work out the area of that circle. So the area rule for a circle, and it's for every circle, it is pi r squared. Okay, now pi we've talked about, r is that radial length. But what we're doing with this radial length is we're actually squaring it. We're multiplying it by itself. So I guess if you wanted to write it out in a different way, you'd say that the area is equal to pi times the radius times the radius. This is too much work. We're just going to stick with writing pi r squared. So for this particular circle that we're dealing with, we write down what all those things are. So we've got pi multiplied by the r, the radius, is 10 centimetres. And you'll notice I've put that in brackets. The reason for that is that I want not just the number to be squared, I also want the units to be squared. Whenever we're dealing with area of shapes, we always end up with squared units. So I can break apart that 10 centimetres squared if I really wanted to. I just put it there so you understand what I'm doing. I can then multiply that out, and you'll see that 10 times 10 is 100, so 3.14 times 100 centimetres squared will give me my answer of 314 centimetres squared. That is the area of that circle. And a different circle, I could do a different example, but it doesn't matter. It's always the same process depending on what you've been given. Now, if, however, you have been given a distance that is a diameter, well, you're going to have to find half that distance, because that is the radius. Apart from that, the only other tricky thing is if you are trying to find the area of partial circles. So I've got a drawing here. We've got a partial circle. We've got a measurement for a radial length, and we also have how much of that circle there, which is important because the rule really is pi r squared, same for a whole circle, but how much of the circle do we have? In this one, we can substitute in, and you'll see I've got 3.14 times the 14 metres squared times the number of the degrees that I have of the circle over 360, which is the total circle. So I can bring that down into smaller and simpler terms, and then I am able to calculate that. And you'll see that the answer is 444.48 metres squared. And I cannot stress enough how important it is to get this metres squared on all of your area questions, because it is the appropriate unit of measurement. Okay?